In this video, we'll be finding the area of triangles and using triangles to find missing values. So before we find the area of a triangle, I want to highlight some of the key components of a triangle. So here we can see that our triangle has three sides and then it has this internal measurement. So our three sides are going to be side 1, side 2, and the base. And we figure out which one is the base by also looking for the height of our triangle. So the height of our triangle is going to be this internal measurement that forms a 90-degree angle with the base and goes straight up to the point to find how tall that triangle is. When we measure height, we go to the tallest point, which in the case of the triangle is that high point. So we can see here that that h value is our height, and then the side length that it forms a 90-degree angle with is going to be our base. So when we identify parts of our triangle to find the area, we're always going to start by finding the base and the height, because those are the values you'll see that we're going to use to calculate that area. Now, to calculate the area of a triangle, I'm going to use the two triangles below. And what you'll see here is that these two triangles are identical. They each have a height, they each have a base, and then they have their two other sides. And what you'll notice is if I rotate this triangle around and turn it upside down, what's really cool is if I put these two triangles together, they form a parallelogram. So let's make that a little smaller. They will form a parallelogram together. So you can kind of see that image right here. Now, we know that to find the area of a parallelogram is base times height. And since our triangle only makes up 1/2 of this, there are two ways we can go about generating this area equation. One is that because our triangle is one of two, we can take our base times our height and we can divide it by 2. However, for finding missing components, it's actually easier if we represent it by multiplying everything by 0.5, which is the same thing as multiplying or dividing by 2. So our area equation, which we're going to write down below, our area equation is going to be area equals 0.5 times our base times our height. And that's because it's half of a parallelogram when that triangle has two of them put together. Now let's use our knowledge of area to calculate the area of the triangle below. So we have area equals 0.5 times the base times the height. So in order to calculate my area, I need to identify the base and the height. And I know that the base and the height form a 90-degree angle together, and I know that the height is my internal measurement going up to that point. So my height is going to be 5, and then my base is the side length that makes that 90-degree angle with the height, which means my base is 18. So if I take 0.5 times 18 times 5, and I multiply all of those together, 0.5 times 18 is 9, 9 times 5 is 45. I find that my area is 45 feet squared. Now, just to make sure we still understand how area and perimeter are different, remember our perimeter is all the side lengths added together. So we would do 7 plus 12 plus 18. Notice I didn't include the 5 because that's not a side length. 7 plus 12 plus 18 gives me a perimeter of 37 feet. So now let's try a different type of triangle. So our area is still calculated for a triangle by using 0.5 times the base times the height. When I look at this triangle, I don't see an internal measurement, but I do see my 90-degree angle. This 90-degree angle that has a line up to the high point is telling me that my height is actually equal to 6. My height is actually a side length. And because the side length that makes a 90-degree angle with that height is 8, my base value is equal to 8. So to calculate my area, we take 0.5 times my base, which is 8, times my height, which is 6, and I end up with an area of 24 inches squared. Now, if we were to calculate our perimeter here, remember we would take all the side lengths and add them up. So we have 6 plus 8 plus 10. So in this one, because our height is also a side length, it gets included in our perimeter, and it is also 24 inches. Now this third example here is a little trickier because the height is not a vertical value. So our area equation here is still 0.5 times the base times the height. But remember, our height is always that internal value going up to a point with a 90-degree angle. So our height here is actually 9 meters. Even though it's a horizontal value, our height is the 9 because it's that internal measurement. If I were to take this triangle and put it flat and twist it around, I could see 9 being that vertical value. Now, my base is the side length that forms a 90-degree angle with my height, which in this case is 13. So for this problem, I'm going to take 0.5 times 13, which is my base, times 9. And if I multiply those together, 0.5 times 13 times 9, I end up with an area of 58.5 meters squared. And then if we calculate the perimeter here, remember we're adding up all the sides. So we have 13 plus 12 plus 10. In this one, our height is not included. If we add those all together, we end up with a perimeter of 35 meters. So now let's flip this around and use our knowledge of area to calculate missing values. So here we've got the area equation, and it's equal to 0.5 times the base times the height. So we're going to start the same way. We're just going to fill in our equation with everything that we know. So I can see from the instructions that the area of my triangle is 60. So I'm going to replace area with 60. I then know that my 0.5 stays the same, and I next need to find my base and my height. So remember, my height is this internal value forming a 90-degree angle going up to the tip. So we have our height is just equal to x, and our base is the side length that forms a 90-degree angle with that, which is 20. So if I fill those values in, 20 times x, I have now created my equation. Now, while this might seem complicated, it's really not. So here we can see that we have 0.5 times 20. That's just a math calculation. We can actually do that on our calculator. So if we take 0.5 times 20, we can rewrite this equation to be 60 equals 10 times x, which I think makes it a lot easier to look at. So we can multiply those numbers together and make this equation simpler. Now from what I can see is we can just divide each side by the 10, and we end up with x is equal to 6 inches, which becomes the height of our triangle. So let's try another example here. So we're going to start with that same area equation of 0.5 times base times the height for this triangle. I can see that the area of my triangle is 30. I then need to find my base and my height, which I know form a 90-degree angle. I know that my height goes up to the tip, so my height is x plus 3, and my base is 12. So I can go to my equation and input 12. And then from here, what I notice is I have x plus 3 as my height. In order to add that to my equation, I need to surround it with parentheses to make sure that that is all grouped together. So here we have x plus 3 in place of h in our equation. Now we can apply the same type of thinking we did before. I notice that I have two numbers that I can multiply together. So 0.5 times 12 is going to give me 6. And that makes my equation a lot easier to look at. When I look at it now, I notice that I can get rid of the parentheses by using the distributive property. So I distribute the 6, and I find 30 is equal to 6x plus 18. Then to solve this equation further, I can subtract 18 on each side. So I have 12 is equal to 6x divide both sides by 6, and I end up with x is equal to 2. And if I were to take that and plug it back in here, 2 plus 3 would mean that my side length over there was 5. So now let's give this tricky example a try. So here we have area is equal to 0.5 times the base times the height. And I already look in my instructions and I can see that the area is 42. So I'm going to substitute that in right away. Then I know that I need to find my base and my height. When I know my height is going to form a 90-degree angle as an internal measure going up to the tip of my triangle. So I know that my height is equal to 6, which means my base is the side length that forms a 90-degree angle with that, which is x plus 6. And I know that because I have x plus 6 and there's multiple parts there, that I want to surround that in parentheses when I put it into my equation. So here we have 0.5 times x plus 6 times our height, which is 6. Now, this might look more complicated, but it's really not. Remember that multiplication is what's called commutative, so we can multiply in any order. So what I typically tell kids is if you see a string of multiplication, multiply that 0.5 and the 6 together. We can still multiply the two number parts together pretty easily. So here we have 42 is equal to 0.5 times 6, which is 3. And then we have x plus 6. So now we can distribute. So we have 42 is equal to 3x plus 18. Subtract 18 from each side, and we end up with 24 is equal to 3x. Divide by 3, and we find that x is equal to 8. So we can take that x value, we could put it back in here, and 8 plus 6 would give us a side length of 14.